Today's lesson is on lines in the coordinate plane. This is our last lesson in Unit 3, and what I've done, if you're reading your textbook, is I've combined the last two lessons into one. So here we go. We're going to start with a conversation about slope, which you learned about a long time ago. The slope of a line is the ratio of the vertical change, which we know as rise, to the horizontal change, which we know as run, between any 2 points. So if you look at the picture here that I pasted in here for you, you can see it's rise over run. Here's our formula. Remember, we use the little m to designate slope, and the formula that we've come to know and love is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And of course, we know that those y's are the rise and those x values are the run, rise over run. You might see sometimes in a math class, you might see it written this way, delta y over delta x, and that just means change. The little triangle means change in y over change in x. So several ways you might see that there, but what we know is that we take the difference of the two y values. We pick 2 points on the line. We take the difference of the two y values in the coordinates and the difference of the two x values, divide the x into that, and that's our slope. So what we also probably have known for a long time, that in a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Or another way of saying it is that parallel lines have the same slope. And we just say non-vertical lines because non-vertical lines have a little special case, a little special issue with their slope, which we'll talk about just in a moment. However, even though it looks like we've excluded vertical lines here, we know that any two vertical lines will be parallel. They are parallel, but technically vertical lines that are parallel do not have the same slope. And again, I'll explain to you why in a moment if you don't already know that. Okay, so in this little picture here, lines K1 and K2 have the same slope. And how do I know that? Oh, because they're marked as being parallel. So whenever I've got two lines and I see that they're parallel, instantly I know that they have the same slope. All right, perpendicular lines. What do we know about the slopes of perpendicular lines? Well, we know that the product of the slopes of perpendicular lines is -1. So if you look down here at my little picture, I've got a line whose slope is 2, and of course that would have to be this one. It's got the positive slope. I can see that it's got a positive slope. This one down here would have to be the one that has the slope of -0.5. And if I multiply these two slopes together, I get -1, and therefore I know that those two lines are perpendicular. And anytime I have two lines, one of which is vertical and one of which is horizontal, they will be perpendicular. However, I can't multiply the slopes of a vertical line and a horizontal line because a vertical line doesn't have a slope. And that's what we're going to see right here. Vertical lines have a slope that is undefined. Undefined. And I think you've heard this before, but in case you haven't, I'm not going to tell you why. What I want you to do is think about why. Why is the slope of a vertical line undefined? And I want you to write that for me right here. I will check it when I look at your notes next time. And what do you know about horizontal lines? A horizontal line, let's say if I sketch that one in right there, what's going to happen? What's the change in y no matter what point I look at on that line? There is no change in y, right? So I know the numerator, the rise, is going to be 0, and that's why the slope of every horizontal line is 0. Okay, so let's take this little example here and find the slope. We want to start by writing the formula for slope so that we will remember it. So slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Does it matter which point I use as the first one and which I use as the second one? It does not matter. However, if I use this as my y sub 2, I gotta have this as my x sub 2. I can't let this be x sub 1 and this be y sub 2. I gotta stay consistent. So we'll let this be x sub 1, y sub 1. And then we're just going to plug in. Just plug in our coordinates. So y sub 2 is 3 up there, minus y sub 1 is negative 3, x sub 2 is 5, x sub 1 is negative 4. So that's 3 plus 3, which is 6, 5 plus 4, which is 9. When I simplify that, 3 goes into 6, 2, and into 9, 3. So there's my slope, 2/3. The slope of that line is 2/3. And hopefully you knew already that it was going to be positive, because you can see that as I go farther to the right in the positive x direction, y is getting larger too, which tells me I got a positive slope. All right, what's our next example? Well, it says look at these 3 lines and decide which ones, if any, are parallel. So I guess we got to find the slope of J1, got to find the slope of J2, got to find the slope of J3, and if any of those slopes are the same, then we know those lines are parallel. So J1, here it is right here. So here are my 2 coordinates on J1. So I got 10 minus 2 over negative 1 minus negative 5, which is plus 5. So that's 8 over 4, which is 2. So I got a slope of 2 right here. And that looks about right. I know it's positive, so I think I got that right. Okay, J2, here are my 2 points on J2. Let me change colors so we can distinguish these two. J2, I got 9 minus 1 over 2 minus negative 2, which is plus 2. So that's 8 over 4, which is also 2. Nice. I know those two are parallel. Now let me check out J3 and see if it's also parallel to the other two. There are my 2 points. So the slope of J3 is 7 minus 2 divided by 5 minus 2, which is 5/3. So this one is not parallel. These two are parallel. J3 is not parallel to those. And that's how we do a problem like that. Okay, equations of lines. Slope-intercept form of a line. I'm sure you've known this for a long time. Y equals mx plus b. The b is the y-intercept. And of course, we know that m is the slope. That's the one we're most familiar with. Point slope form. If you think about the formula for slope, we really just solve this for the y's, and we know we're going to have one of the points. So if we multiplied both sides by the denominator here, we would have y minus y1. Oops, sorry about that. Equals the slope times x minus x1. And we're going to use this whenever we have the slope and we know a point on the line. We're going to use point slope form to find the equation of the line. Standard form of a line, you don't see it very often, but it's c equals ax plus by. Okay, here's another example. Line K1 has the equation y equals negative 2x plus 5. I'm going to scoot right over here and make myself a little sketch. So positive 5, my y-intercept, negative 2. So K1 looks something like this. And I don't have to draw a sketch, but you know me by now. I do like to draw a sketch when I can. Okay, K2 is parallel to K1 and passes through the point negative 4, 3. So about right there. So there's K2. I know it's parallel. So what does that tell me about K2? K2 has the same slope as K1, right? What is the slope of K1? -2, right? Right there it is, -2. So now I'm going to take -2 and the point that I'm given, I'm going to plug it in to the point slope form of the line, and it's going to say y minus 3, here's the 3 I'm talking about, equals the slope, which is -2, times x minus x1, right there. So minus -4. So now I just got to solve this for y, and y is -2x. Let's see, this is -2 times +4, so that's -8 plus 3, so -5. So there it is. Y is -2x minus 5, which tells me that this point right here is 0, -5. It's not a great drawing, but my y-intercept is -5. I knew the slope was the same. Please notice how I did not solve for the y-intercept. I used point slope form. You're always going to use point slope form when you're given the slope and a point on the line. Okay? What do we have next? Ah, another one. And oh, by the way, I changed this point. I changed this point from what's in your packet, so you go ahead and change that, because it turned out that when you did this problem with the point that's in your packet, you got the same equation. It was the same line. So here we go. Let's do this one together, and I'll let you do the next one by yourself. So let's see, we're looking for a line that's parallel, so we know the slope is the same, -3/2. So we're going to plug into my equation, y minus -5, so that's y plus 5, equals the slope, which is -3/2, times x minus -1, so that's x plus 1. So there I've got my slope, I've plugged in my point. So now I'm going to solve for y. It's -3/2 x minus 3/2 minus 5, right? I got to bring this 5 over here. And of course, if I want to add these fractions, I need to change 5 to halves. So I'm going to change that to 10/2. So finally, the equation for this line that's parallel to the other one goes through -1, -5, is -3/2 x minus 13/2. So what's the y-intercept? -13/2. And of course the slope is the same as our original line. Okay, you pause here and do the next problem. Okay, so I drew myself a sketch. I'm looking this time for the equation of a line that's perpendicular to a given line. So the given line has this equation, 3x plus 5, and I know that the other line is perpendicular, so its slope, and I think I failed to mention this on the previous page, I did mention that the slope, the product of the slopes of two perpendicular lines equals -1, but that's because the slopes are opposite reciprocals or negative reciprocals. Negative reciprocals. Okay, so if I got a slope of 3 for the other line, the slope of the perpendicular line, the negative reciprocal, would be -1/3, which I put right here. And so now I'm just going to plug that and my point into the point slope equation, which I did right here. And when I solve it for y, I get y equals -1/3 x plus 2. And my y-intercept would have been at 2, so not a great sketch. My y-intercept looks like it should have been more down here somewhere, but that's okay. I know that I have this right because I know I got the slope right. I plugged in the point, x minus 3, y minus 1, and then I solved it for y. So hopefully we're good there. Okay, one more, and then this is the end of the lesson. Think about a plan. Line L1 L1 contains negative 4, 1, and 2, 5. 2, 5, negative 4, 1. Play like I hit that point right there. So there's L1. L2 contains 3, 0, 3, 0, and negative 3k. What value of k makes L1 and L2 parallel? So that's going to have to be down here somewhere, right? If these two are going to be, well, no, hold on, because that is negative 4. So I got to be over here somewhere at negative 3. So maybe about right there. So there's negative 3k. So now that we have that nice sketch set up for ourselves, I want you to find this value of k. I will check your papers tomorrow and see what you came up with for k. If you have any trouble, don't quit just because at first you might get stumped a little bit. Just don't forget what you want to do is think about slope. And that's all for this lesson, all for Unit 3. We'll see you next time.